Hornets, and thank you for joining me today. I'm going to be going over the law of sines as well as finding the areas of triangles. Now, first thing we're going to do is we're going to take a triangle. I'm just going to go ahead and find just any old triangle, and we're going to call that triangle A. Let's go use capital letters A, B, and C. And we're going to go ahead and we're going to say that opposite sides of a triangle are the lengths. So if this is my angle C, this is my side C, this is angle B, then this is going to be side B. And if this is angle A, this is going to be side A. Now the first thing I want to do is I want to start off by trying to figure out what is the area of this triangle. Now we know that the area formula for a triangle, we're going to use K as opposed to A, so that we don't mistake it for this side or that angle. K is 1/2 base times the height. Now in a right triangle, that's pretty easy. But when we don't have a right triangle, in this case an acute triangle, it's also known as oblique, or I suppose we could call it scalene, I'm going to have to figure it out. Now my base is easy to find, that's C. But how do I find that height? That's where the real question comes in. Well, if I'm working with angle A, I can see that I have my opposite side and my hypotenuse B, which means that I can work with the height being the height divided by B is equal to the sine of angle A. And therefore, the height has to equal B times the sine of A. If I now put that in for the height, I get B times the sine of A. Now I notice that there's a pattern here. I see 1/2 CB sine of A. All three letters are used. I wonder, is that going to happen if I twist the triangle again? Let's turn it. Let's see what happens. We now have B here, we have C here, and we're up here at A. Now once again, we're assuming that these are going to be two congruent triangles, even though it's not drawn to scale. So A is now down here, B is here, and C is here. My altitude goes straight down from the vertex, and you'll notice it's always a right angle to either the side or to the extension of that side, if it's an obtuse triangle. I'm now looking at my height. I can see I have side C is going to be the hypotenuse of this triangle, and it's angle B. So the height divided by C has to be the sine of angle B. Once again, we have K equaling 1/2 our base times, and this turns out to have height equals C times the sine of B, and I'm going to put it in. Hey, we have a similar pattern. Notice the first one we have, if we rewrite it so that it follows alphabetical order, would be BC sine of angle A, and we now have 1/2 AC sine of angle B. Let's flip it one more time. That way we can truly test it. We're going to have this side. B is now up here. And we're looking at C and A. Here's side C, here's side B, here's side A. Our altitude goes like that, also known as our height. Our height is now, in terms of the angle C, height divided by A equals the sine of angle C, which means that our height is A sine of C. Our area formula is 1/2 times side B, A sine of C. Lo and behold, that pattern is holding. Woohoo! We now can very easily learn and memorize the area formula. Whoops, that was angle C, excuse me. And how we would know is that if I'm using an angle, I use the other two sides as a product times 1/2. 1/2 BC sine A 1/2 AC sine B and 1/2 AB sine C. All right, we now have an easy way for us to figure out the area of our triangle when it is not a right triangle. That's pretty cool. Be aware, if we had all three sides and no angles, we would be using something called Heron's formula. Heron's formula works with the length of the three sides divided by 2, called the semi-perimeter S. We would then have the square root of each of these sides minus the semi-perimeter. So we would have A minus the semi-perimeter. The semi-perimeter minus A. That would have given me a negative, and that would have been bad. We have the semi-perimeter times B, and the semi-perimeter minus C. And this, according to Heron, is our length K, or our area K. Now, a couple of things to just be aware of. Heron is a really neat figure in history because Heron was able to figure out, in fact, proved that the Earth was round. And he did so many, many, many years before the Western culture decided that it was, and I did forget to multiply by S. Let's make sure I get that correct. So semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Once again, Heron was a mathematician all the way back from ancient Egypt around the first millennia, so around 50 BC, CE, in the Common Era. And Heron found that the Earth was round. Heron also invented a steam-powered toy where when he heated the water, he had jets around a circular spinner, and it caused a motion of an engine. What he didn't have was interlocking gears. I believe if he had, we probably would have had the Industrial Revolution a heck of a lot sooner than we have than the 18th century, the 17th century. Anyway, just things about history that are interesting. If you would like to learn more, I recommend you Google Heron and find out all about him. Once again, a really cool dude and a person who has advanced math considerably until it was lost in the dark ages of the Western society. Keep in mind that if you look, other cultures were able to find similar information and do similar things in their own cultures and in their own way, like finding zero, the concept of nothing, and how we represent it. Alrighty, let's take a look at our area formulas, and we're going to kind of take a look at this a little bit more. Since we were talking about three triangles, all of which were supposed to be congruent, we could say that 1/2 BC sine of A has to equal 1/2 AC sine of B. Notice they both share C, and they both share a half. That means that I have B sine of A is equal to, A sine of B. And if I divide by A and divide by B, or multiply by the reciprocals, I end up getting the sine of A divided by A is equal to the sine of B divided by B. If I do the same thing with any two other triangles, areas, let's do 1/2 BC sine A again. And we're going to set it equal to 1/2 AB sine C. Notice that the 1/2s cancel, the b's cancel, and we have C sine of A is equal to A sine of C, and therefore we have sine of A divided by A is equal to the sine of C divided by C. Well, putting it together using the transitive property where A is repeated twice, I can say that the sine of A divided by A is equal to the sine of B divided by B, which is equal to the sine of C divided by C. This is often referred to as the law of sine. This is what we are going to work with today. Please remember that we can take reciprocals, and therefore we could also use A divided by the sine of A is equal to B divided by the sine of B is equal to C divided by the sine of C. Both of these constitute the law of sines. Do, 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 do. All righty. How do we use it? Well, for that, we're going to be taking a look at the worksheet that I put on in the classroom today. And you'll notice that I have provided an answer key. This will require us to work with our calculator, so please be aware. You want your calculator on functions. I'm just going to show it to you real quick. We want it on function and degree. All right, if you're in radian mode, you're going to have to convert all of your degrees into radians, and I do not consider that to be a blessing. It is not fun. Now, please be aware that we do have to check things out because we have to make sure that the opposite side of the largest angle is the largest side. The smallest side pairs opposite the smallest angle, and the medium angle goes with the medium side. Okay? Now, I also request that everybody write their angles off on one side, put a line down the middle, and then find your sides. We therefore know that if I have angle A is 118 degrees, angle B is 22 degrees, I can find the measure of angle C, and it will be exact by simply remembering that a triangle has 180 degrees in it. So by working with 180 minus 118 minus 22, I find that this missing angle is 40 degrees. I also know that side C is 24. Now we're always going to use the best answer we can. That means that we want the largest decimal possible or exact values if at all possible, and that's first. So if you can't use exact values, you have to use the largest decimal you can. That means you're going to have to store your decimals into the calculator and then recall them. All right, to do that, you're going to be using the STO button. The STO button is right here. And then there you go, the STO button right there. And then you're going to be using the alpha and a letter. I'm going to press pause right now so I can turn my lights back on. Alrighty, thank you for that. Now be aware we are also going to be using the second answer in order to work with these things. So we have the second and the negative. That's going to give us our previous answer so that we can always use the most exact decimals possible. Okay, keep that in mind when we're trying to find our angles. All right, here we go. We're now going to set this up according to the law of sines, and we're going to try to figure out which one is best. Well, we're probably going to want to use the one down below so that our side is in the numerator. When we are trying to find angles, we're going to have this one so that our sine of the angle is on top, and it'll allow us to take the arcsine cleanly. We're now going to go ahead and we're going to set this up. I want to find side A, so I have A divided by the sine of 118 degrees is equal to side C, which is 24, divided by the sine of 40 degrees. I'm going to cross multiply or multiply by the reciprocal so that A is going to equal 24 times the sine of 118 degrees divided by the sine of 40 degrees. Now this is the exact answer. The minute we use our calculator, we always get an error. We're going to have to round our values. We have no choice. Okay, so please keep that in mind. You need to put this into your calculator exactly as you see it. So we're going to put this in exactly. So to do that, I'm going to hit alpha y equals. You'll notice I'm going to choose 1, which gives me a fraction, and I can now put 24 times the sine of 118. Move the arrow down and work with the sine of 40. Now by simply clicking enter, I get my first answer, and I now know that A has to be approximately So I'm going to use the wavy lines, 32.9669. Now you'll notice I am doing what is called truncating. Truncating means that I'm cutting the angle off at the 4th decimal place and dropping everything after it. This is not rounding. This is called truncating. And I will be truncating all of my values. Now, in order to do the next one, we're going to have to do the same thing with b. That means that in order to find b, we are going to work with the sine of 22 degrees multiplied by the 24. Then we're going to divide by the sine of 40 degrees. Putting this into my calculator exactly as I see it. There we go. I have alpha y equals giving me the fraction of 24 times the sine of 22 degrees. And then in the bottom, the sine of 40 degrees. Then click enter. I get 13.9868. Once again, it is an approximate amount, 13.9868. And this is the answer to my first problem. You should try number 2 and see if you can find that answer. Start by putting all of your letters, angle A, angle B, angle C, putting in the angles, then identifying A, B, and C. We can see that our B is the 7, C and A are going to be approximations. Our angle B is 44 degrees. Our angle C is 53 degrees. And we're going to find angle A by taking 180 minus our sum of the two other angles. Now, once you've done that, you should be able to go and take a look at the answer key that I have online. And you'll notice I've already taken the liberty of showing the two pieces that we're going to work with and identifying their answers as truncated decimals. And you're going to want to work through all of these problems and see what happens. Be aware, whenever you find a 90-degree angle like you do in number 3, we immediately go to our SOHCAHTOA. So we're either going to work with the sine of the 51 degrees is equal to our opposite side, C, divided by our hypotenuse, 27. And then I'm going to work with the sine of 39 degrees is equal to A divided by 27. Now, by working with my sines, it keeps me consistent, and I'm always looking from the perspective of the angle that I want and the opposite side to it. All right, once again, list all of your pieces. A, B, C, put side A, B, C, D, A, B, C, using the law of the SOHCAHTOA. You should find your answers as such. Once again, here's my work right here. And if you look at the answer key, you'll be able to find that. This is finding solutions to triangles. When you are finding the solutions to triangles, you are finding every angle and every side. Let's go ahead and go down to number 6. Number 6, gee, they only give me one angle. All right, so we're going to go ahead and we're going to find and say angle A is 88 degrees. We're going to need to find angle B, which will be an approximation, and angle C, which will be an approximation. We have been given all 3 sides here. So our side A, I'm going to write that down, and side A is going to be 26. B is going to be 16.1, and C is going to be 21. Now notice, when I do the law of sine, as we said before, we're going to want to make sure we use this one where the angles are on top. This will allow me to have the sine of angle B divided by 16.1 is equal to the sine of angle A. That was what was given to me. Let's replace A with 88 degrees and not take it in two steps. And divide it by 26. Now you'll notice I'm going to multiply by 16.1, and I'm going to have the sine of angle B is equal to 16.1 times the sine of 88 degrees divided by 26. In order to find angle B, we will now have to take the arc sine. So angle B is the arc sine of 16.1 sine of 88 divided by, and that's in degrees, divided by 26. And we need to put this directly into our calculator exactly as we see it. So here we go. Start off. Make sure you can see this. Second function sine. Alpha y equals for my fraction. And put 16.1 sine of 88, close parenthesis. Put 26 in the denominator and go all the way to the right and put your closed parenthesis. Once you hit enter, you are going to get the angle B that we are looking for. So I'm going to write this down as 38.2324 degrees truncated. Now I'm going to want to figure out what is the next angle. And I want to use this angle that's already been given. So I'm going to have to take 180 degrees. I'm going to subtract the known 88. And here's the trick. We're going to hit second, followed by the answer right down here. And we will be able to put in the previous answer to the largest decimal place possible. So minus alpha negative. By hitting enter, I get my answer as close as I can, and it is now 53.7675 degrees. And there we go. This is our solution to this triangle. Remember, solutions find every angle and every side. I'd like you to try number 7 real quickly and try to set it up. First of all, put all of your information off to the side, identifying which ones are going to be approximations and which ones are exact. By being organized, this will help you in the future. A is 29, B is 24, C is 20. Notice we can see our largest angle, 82. We're going to put that 82 degrees there. To find angle B again. So I have sine of angle B divided by 24 is equal to the sine of 82 degrees, the known information that is given to us immediately, divided by 29. We now have to get and isolate our angle B. That's going to be the arc sine of 24. Let's make sure you can see this. 24 times the sine of 82 degrees divided by 29. By simply putting this into the calculator and clicking enter, you will find your first angle, angle B. Then do 180 degrees minus 82 minus second answer, and you will find angle C. Try this now. See what happens. Hopefully you pressed pause and you checked your work. Notice I have identified what I used to find angle B, and I've put angle B as 55.0379 degrees. When I did 180 minus 82 minus angle B's answer, I ended up with 42.9620 degrees. Now please be aware, because we are not rounding our answers, this will almost always be either exact or off by 1 degree. So if you were to add all of these up, you're going to find that you're off by about 1/10,000th of a degree. For us right now, that's going to be okay. Please continue to do all of the rest for those of you in my class. Now, in the next group of problems, I'm asking that you draw the triangle. I'm giving you a more real-life situation. We're still going to find our angle here by simply subtracting from 180 degrees. And I'm going to find that this is going to end up being 30-degree angle. I'm going to set up my triangle, and I'm going to put my more acute angle off to the side here. And I now have B, C, and A. C was the obtuse angle at 110 degrees, B was the larger angle at 40 degrees, and C was the smallest angle we found at 30. Our opposite side is 30. We're now going to have to find our sides once again by using the law of sines and setting it up. So A would be 30 sine of 30 degrees divided by the sine of 110 degrees. You're going to put your answer right here as an approximation. To find B, you're now going to use the 40 degrees here, and we're still using the 30. So we have 30 sine of 40 degrees divided by the sine of 110 degrees. And you're going to put your answer right there. We're going to do the same thing in the next triangle. Once again, try to draw the triangle according to the obtuse angle that's given. Put the two acute angles at the two sides, like I did in the first problem, right here. And I would try to keep the same looking triangle each and every single time to be as consistent as possible. Let's go ahead and move on. Sometimes life does not go well for us. Notice in this problem right here, we're trying to set up the triangle, and we have measure A. Let's set this up. I'm going to look at it. I have 85 degrees. It's fairly large, but it is still acute. And opposite side of that side, I have 15. Well, wait a minute. B over here is, let's call this A, B, and C. B is 25, and 25 is a lot larger than 15. If you were to try to do the law of sine, you will find out that this will not work, that this has no solution, because the largest side is not opposite the largest angle. Triangle doesn't exist. You cannot succeed with it. So always look for what is opposite the largest angle. It has to be the largest side. If it isn't, the triangle does not exist. Now, sometimes, occasionally, we are forced to use information that we normally wouldn't want to. Notice in this problem, I'm going to set it up. And the information that I'm given is right here at 31 meters. We have this 12 meters here. My acute angle is 20 degrees. And I have my A, C, and B. All right, well, we're going to try and find angle B. Notice I'm just going down my list, A, B, C, and then I'm going to find side B. Here we go. Angle B is equal to the arc sine, once again, using our law of sines, 31 sine of 20 degrees divided by 12. All right, let's go ahead and do this, shall we? Putting it in directly. Second function sine of alpha y equals gives me the fraction 31 times the sine of 20 degrees divided by 12. Whoa, and I put the parenthesis in the wrong place. There we go, divided by 12. Now hit enter. Now this is my answer, but I'm going to have to be able to figure out what I have. So I'm going to have to make sure I store this in my calculator, and I hit Store Alpha A. I'm going to now list it. Remember, I'm going to truncate this answer, 62.07, and then I have 38 degrees. I'm going to now find angle C. Angle C is also an approximation, and I'm going to find it by taking 180 degrees minus the 20 degrees minus the arc sine answer that I just found, 31 sine of 20 degrees divided by 12. Now, when I find this answer, 180 minus 20 degrees minus second answer, I want to keep this answer in my calculator. I'm going to have to use the largest decimal I can. And in order to do that, I am now going to store it in alpha B, a different letter than what I have for A. Hit enter. I'm now going to write this down under my C information. It is approximately 97.9261 degrees. But I have to find C. Now, in order to find C, I have to work with the law of sine again. C has to be equal to 12 times the sine of our alpha B. I'm going to put it as alpha B. And I forgot my L. Alpha B, just to remind me. And then I'm going to divide it by the side sine of 20 degrees. And this is what we're going to put into our calculator. So here we go. Start with the fraction, put in the 12, sine, and then hit alpha followed by B. Close parenthesis, go to the denominator, and do sine of 20 degrees. Then hit enter. You now have side C, as accurate as it can be given based upon the information we have. This is 75.04, and once again I am truncating, not rounding. And this is my answer. Notice this is the solution to the triangle. Whenever we say solve the triangle, we want all angles and all sides. I hope this has helped. I hope you found this useful. If you did, please remember to click like, and hopefully you will find this useful and you will do so. If you have suggestions or you think there's issues that you have questions about, please feel free to let me know in class or at some other time, and I will do my best to answer it. Thank you very much, Hornets. Please be safe, be kind to each other, and remember it's easy to be mean. We see it every day around us. If you see it, think about how you might intercede or advocate for others, and at the very least, try and think about how you can avoid doing the same thing. Thank you very much. Please be safe and be kind. Bye-bye now.